Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this DevOps.com program, brought to you by Techstrong, Shoreline, and TigerGraph. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude the live recording today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab. You'll find that Q&A tab on the right side of the screen with a couple more options. That's where you'll see the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts, or maybe just from where you're tuning in. And you'll also see the polls tab. So we'll be launching a couple of polls throughout today's program. So please feel free to answer those whenever we get those launched. Of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So our topic of discussion today is scaling in the cloud with a small ops team. And I'm joined by Dr. Jay Yu, Vice President of Product and Innovation at TigerGraph, and Anurag Gupta, Chief Executive Officer at Shoreline. So Jay and Anurag, thank you both so much for joining me. Jay, do you want to go ahead and get us kicked off?
Thank you, Cody, for hosting this. Thank you, everybody, to join us. Yeah, as Cody mentioned, I'm Jay Yu. I'm the head of product innovation at TigerGraph. I'm going to talk about TigerGraph a little bit later. My background, I'm a deep technologist. I got a PhD in scalable database engine back in the late 90s. And I joined Teradata and then joined some startup. And I spent most of my career at Intuit focused on enterprise data architecture and strategy. That's where I discovered Graph, discovered TigerGraph. I joined TigerGraph about a year ago, was focused on product vision, strategy. Actually, cloud is a big part of it, and also innovation. So with that, I love to turn to Anurag to talk about himself.
Hi, I'm Anurag. I'm the founder and CEO of Shoreline.io, and we'll be talking a little bit about Shoreline today. And before this, I was at AWS, where I ran about a dozen services for them, focused mostly around analytics and transactional databases. But by the end of my tenure, there was about 5 million instances. And Shoreline is, in many respects, the product I'd wished I'd had when I was at AWS. So with that, let's talk about the agenda. So Jay's going to talk a little bit about TigerGraph and TigerGraph Cloud, what they were looking for when they decided to, work on the operations, and then we'll switch over to talk about generally across all the various people I talk to, what are the problems that they face in cloud operations. We actually ran a survey on this earlier in the year, and anybody who participated will be able to get that as a handout. I'll talk a little bit about Shoreline and how we approach the general problem of production operations and where we fit in the life cycle. And then I'll hand off to Jay to talk about how TigerGraph is using Shoreline. And then, hopefully there'll be a lot of questions and ample time to cover them. With that, I will hand back to Jay to talk about what TigerGraph is.
Fantastic. Thank you, Anurag, for sharing the agenda. Let me spend just a few minutes talking about TigerGraph. So what is TigerGraph? We are actually a small startup, mid-range startup. We raised around $100 million about 18 months ago in Series C. Our focus is in this new paradigm called graph database. Graph database actually is different from relational database or other NoSQL database. Instead of organizing data into rows and columns, which tables, and then rely on joins to stitch things together, that's what relational database is about. And then NoSQL database taking a complete the other approach, try to put all the information together using JSON and so on and so forth. Graph database model data in nodes and edges. So that means we already connect all the data together. Joins are already materialized. That's why we're super fast for you to explore deep relationship. Imagine five-way, six-way joins will take a long time in relational database for large-scale data. in TigerGraph, it can be done in seconds or milliseconds, right? So that's what TigerGraph, the foundation, is about. So what I'm sharing here is really a architect picture about TigerGraph's product. At the center is a parallel distributed native graph database system built from scratch. Our founder and myself all came from Teradata. Think about it's a Teradata for graph database. That database is available either on-premise for self-managed cloud or fully managed cloud service like a SaaS, a database as a SaaS on our cloud platform. That's what we're going to be focused on for this talk. But on top of that, we're not just providing a database engine, highly scalable one, but also we provide a suite of tools to simplify, to streamline people's advanced analytics and also graph ML machine learning needs. So that's why we're a platform. We have tools to allow developers easily to develop and load data, mapping from relational to graph using visual mechanism, explore the data in visual format, and then query the data with a very powerful G-SQL language. We have now no-code visualization to allow people analyze the graph, which is by nature is very visual, right? We also have advanced graph algorithms, which is actually bringing machine learning to the database. And also we have a way to integrate graph neural net into the massive amount of data. In addition, to make sure people adopt this technology without really trying to understand what's underneath it, we have a suite of application already pre-built for AML, for fraud detection. Those are very well-defined graph problem. We demonstrate superior capability than the other technology. And finally, we have a suite of connectors, making sure TigerGraph can be placed in the middle of your data technology stack. So let me actually quickly go through what customers are using us. There's actually three big categories. First, people use our technology to connect all their data together, silo data together. That's what I did at Intuit. That's what United Health Group connected 200 data sets together, have more than 5 terabytes of data, 16 billion nodes, I think 50 billion edges. And they form a patient 360 portal for 50 million members. Not only understand every single patient's journey, right? Or where you visited, what kind of treatment you get, what kind of drugs, how effective they are. But also they can actually run those graph algorithms to compare, to predict whether a patient needs more care or not. So that's one concrete use case. The second category is once you connect the data, as I said, using graph, you can actually go really deep link analysis. We call it advanced analytics. A lot of problem, almost all problem underneath it can be actually leveraged this connected nature of the data. We can connect data in multi-dimensional way without using drawings. So one of the famous success story is Land Rover Jaguar. They were able to use TigerGraph to do basically supply chain optimization and planning. Supply chain optimization itself is actually a dependency graph, right? When you order something from Land Jaguar with all the different options, they need to translate to those materials. Thousands of parts need to be delivered by suppliers, and suppliers may rely on their subcontractors, sub-suppliers. They have to keep track of where all the inventory is, whether I have enough parts. So that kind of planning usually takes 3 weeks. With TigerGraph, they're reduced down to 45 minutes. And one last category, last but not least, once you connect the data, once you can run queries, analyze the deep relationship on the data, do optimization, you can also bring machine learning to the data. Instead of you have to suck the data out of your database to build ad hoc machine learning pipelines. There's a class of machine learning is really called a graph algorithm. One of them is centrality, which is PageRank, or calculate the influence of a node in the context of the whole graph. That's very, very powerful, right? That's actually that kind of algorithm. You only need to write 10 lines. We provide that open source library you can use. Basically bring that algorithm to your massive amount of data in our parallel architecture, meaning we have a cluster of 40 nodes, can do this computation parallel underneath it without you have to worry about any infrastructure. And by using that, we found a lot of big companies, Intuit is one of them, but also some out of the 10 tier 1 banks are able to use TigerGraph to do really deep fraud analytics. and part of that also to not only traverse the detect the fraud rings, the relationship to the fraud rings, but also have graph-based features extracted from TigerGraph feeding to a deep learning pipeline, with demonstrated 20% to 50% lift in the your machine learning model performance and precision and recall. So that's actually really proven benefit. We see a lot of adoption, even though we're a small startup. We have more than 100 enterprise customers and thousands of developers using our platform. One of the key growth area is actually on the cloud. We know this it's uptick because it's all fully managed. You go there within seconds or minutes, we already can spin up a cluster of 10 nodes, 20 nodes for you. We help you to load the data to it. You can immediately start applying those graph algorithms or machine learning on the graph data, or perform really advanced graph analytics. So we see a lot of growth, but there's a huge challenge, because whenever we have to manage hundreds of thousands of customers, and then each, some of those are big customer, organization may have multiple teams. Each team will actually want to create their own, cluster solutions for their use case. Or we have a still very small, SRE team or DevOps team, and also technical support team. How do we scale that? What we want is a system can quickly, precisely identify issues within seconds if there's any issues, right? We also, when things happen, we want to not only detect, but also automatically apply a fix, instead of having somebody manually have to jump in to maintain those cluster server. We also want to have, sometimes issue do happen, customer escalate to us, how fast we can respond that, right? We have a very strict SLA with a very small team, only a team of 4 or 5 people. How do we make that happen to handle hundreds of customer servers? And finally, we want to make sure whenever we do something, sometimes we have to roll out things across the entire cluster, across multiple customers, organizations. How do we do that quickly? And finally, we want to making sure our technical support folks or even our engineer have the ability to quickly debug and repair things when those happen. So these present huge challenges. And the good news, we discovered Shoreline. I'll pass on to Anurag to talk about what is Shoreline, and then I'll come back at the end, talk about how we actually use Shoreline to address these challenges. Anurag, please.
Thank you so much, Chair. So let's just, I'll start by talking a little bit about a survey we ran recently and some of the results from it, and then I'll talk about Shoreline. And I would say that, Jay and TigerGraph were really prescient in understanding their needs ahead of actually experiencing it, because a lot of customers only see these problems well into their cloud journey, and when things are already sort of burning down around them, which is hard, right? And if you think about TigerGraph, it's a very sophisticated product. Clearly, people want TigerGraph to manage it rather than themselves when possible. And downtime matters. If they're, you saw the numbers there about fraud detection and online activity. So it really becomes very important. People are losing money if it's not up. So let's see how that works. Before that, let's do a quick poll to talk with everyone about what your biggest challenges are in cloud reliability. Is it that your infrastructure is getting more complex, your environments are growing, team issues like people aren't well trained, you can't hire them. There are a lot of bugs as you get deployment mistakes happen, or is it in production where your on-call staff actually makes mistakes when they're handling incidents? So I'll wait for Cody to sort of tell us when we can proceed with that.
Sure. Once we get a couple more survey responses, we can put those right up on the screen.
Awesome. Jay, while we're waiting, never mind. Let's super interesting and actually aligns very well with what our general survey results have been, that environments are getting complex, they're growing, and then there are a lot of people issues where people it's hard to hire and they're not well trained, and then it does feel like deployment issues are somewhat going down compared to where they used to be, and people do make mistakes. With that, I will move along. And let's look at the overall survey results we did. So we conducted a survey of a few hundred people who are, doing production ops. And one thing that they told us is that as they move to multi-cloud, as they move to Kubernetes, as they move to microservices, management of their infrastructure and production operations is getting considerably harder. And that's not because Kubernetes or doesn't make sense. It's actually awesome. Or doing microservices to do more frequent deployments of limited scope doesn't make sense. Or running in the clouds where your customers are. Obviously that makes sense. But the problem is that you have to know a lot more. And in the case of the clouds or Kubernetes, and you're actually just managing more piece parts, which can break. And so that was a important survey result. The other interesting one was we asked how many people experienced what they considered to be a major incident in production in the past year, and how many incidents did they see. And what's kind of shocking is that the average is on the order of 1 every 6 weeks. And in part, that's because there's a long tail here where it's like 1 every, more than 51 a week, which is kind of nuts. But it's fairly significant. So, you clearly, that's an area that people need help with. The other thing that I found super interesting is that almost half of incidents are straightforward and repetitive, the average being about 48% across the survey results. And you can see it kind of is, it's a bell curve distribution as you'd expect. But these are really worth attacking because if it's straightforward and repetitive, not only are those things that you don't necessarily want, the cost or the error rate or the time that is required by human beings to handle it, and you really want to have them become automated. And so I was very encouraged as an automation provider to see this number. On the rest of them, what we find is that they're almost, the other half tend to get escalated, and the time to repair for an escalated incident is almost 3 times longer than if it was not escalated. And so, this relates a little bit to what Jay was talking about earlier in how important it is to be able to push things down to the initial responder, because not only does that reduce the number of people that get involved in something, but it reduces the time considerably. So I thought that was pretty interesting. And then, obviously, people, there's a clarity that, it's clear that people need automation, but people are scared of automation because, what happens if the system runs amok? But the problem is that if you don't have a system, you have a human being, right? And what we find is, and what our survey results showed is that human beings are almost 5 times more likely to cause a major incident than automation. It's just the nature of the beast. And that matches very well to my experience when I was at AWS, that, major incidents often were due to some fat finger or other mistake done by a human. And so, that's why we favored automation so much. And then there was, in the little survey we did here, we saw that people have this problem that the cloud infrastructure is growing far faster than the size of their SRE team. And you're not alone. That's something that everybody is experiencing, where, like almost 2/3 of people saw that their cloud infrastructure grew more than 50% last year, whereas only 1/3 were able to grow their SRE team by that much, which is presumably the group that we're growing even faster than that. And so I think we do need things to help us as our environments become more complex, as they get larger, and so automation, reducing escalations, all of that, we think is a big part of this picture. So that gets to our second poll of, just a question to you all about what things your companies have done to reduce on-call load, improve production ops, either both efficiency, cost, or reliability. So Cody, over to you. So same as last time, we'll wait for a few results and get enough people to chime in, and then we'll take a quick look at the results. And then after that, I'll talk a bit about Shoreline. And then with that, we'll move over back to Jay after I finish up.
All right, we're starting to get a couple of responses. My apologies for getting that started a couple seconds late.
It's interesting. It's this interesting spread across all of the above, and but no one's really doing all of each and every one of these things. So I think there's maybe there's a interesting thing for you guys to think about in terms of the things you're not doing on this list that would be useful to build in. So with that, let's keep moving. So what's Shoreline? How did it help TigerGraph and others reduce achieve high reliability, availability with smaller ops teams? So Shoreline is a DevOps company that's really focused on day 2 production ops. So what happens after things go into production? So there are a lot of companies that are doing day 2 production ops, but the fact of the matter is that almost everybody is doing some form of observability, telling you when things go wrong. Now you need that, right? Because then there are a whole bunch of companies that will help you with routing and deduplication and prioritization of your issues. Also super important. The problem is hardly anybody is out there helping you actually fix issues, diagnosing net new issues, helping you repair them, helping you automate them. And so that part of the world tends to be very manual and relies on the experience of people, is subject to the mistakes they can make, and it doesn't scale, right? Because observability scales, you've got tools for it, but the actual repair does not scale because you need people for that. So that's where Shoreline fits in. So we basically do 3 important things. So starting from the right, the North Star is automation. What we would really like is that, the lights stay on without people having to come in and fix things. So we automate the straightforward repetitive issues that represent almost half of all the incidents. And the way we do that is that, obviously if you're going to do automation, then you need highly reliable alarms. So we have per second data and alarm checks. You can make those very precise by combining metrics, logs, and system checks. So for example, it's not enough to know that CPU is high. That could be a good thing, it could be a bad thing. But if CPU is high and top is telling you it's the JVM process, and the JVM process is, let's say, garbage collecting, and then you know what to do, right? You can take a heap dump, stack dump, thread dump, push it to S3 if you're running on AWS, and then bounce the pod. The other thing you need is that, these teams are very busy, and, everyone knows we want to automate, but the only way that you're going to end up automating, because it's a long tail problem, is if you can build these automations in about the same time as it took you to fix it once. And then lastly, we provide a lot of mechanisms to help you bring GitOps and engineering rigor by, taking this also through the code review process to, dev test production and all the rest of it. And we definitely integrate with pretty much all the observability and incident management tools that are out there already, because we believe we're doing something fairly differentiated from them. Moving to the left, not everything, can be fully automated. Sometimes you want human judgment involved. So for that, we have Shoreline Notebooks, which are a lot like Jupyter Notebooks designed for operations. And you can, when an incident happens, the notebook will pre-populate with all of the diagnostic actions, and it'll have markdown cells to indicate exactly what things can do. And each one is memorialized. And the nice thing is that you don't require SSH access. And so that means that you can actually spread the load to your support team or your engineering team, or, avoid escalations, because every time you escalate, you can update the notebook a little bit more. And that gives you a continuous improvement process to reduce escalations and reduce errors. And then finally, new things do happen, right? For the first time. And so what you need there is you need in my view, the ability to debug your fleet as though it were a single box, look across the entire fleet, get real-time data and run things in a parallel distributed fault tolerant way. And that's really the underpinning technology in Shoreline. And run individual commands to figure out what's going on, and and then also to repair it. And so, that's very powerful. You're not going to give that capability to just everybody on your team, but when you need it, it's there. And definitely there are many times at AWS where I really wished I'd had that ability to have parallel distributed execution across my fleet the same way I did in the SQL databases I was building. So, and on top of that core platform, we have a number of pre-built notebooks and automations. Our belief is that every time anyone anywhere runs into an issue, everyone everywhere should get the benefit of it, because we're all sitting on the same major clouds, we're all using the same databases. We have so we're all probably running into the same issues, and wouldn't it be nice if we could share that from each other? So we don't charge for these things. We have about 50 of them now. We expect to grow it by 2 or 3 each month. And so the goal, with working with our customers, and the goal really is that everyone just gets those if they're on the platform. And with that, I'm going to hand off back to Jay to talk about how TigerGraph is using Shoreline.
Awesome. Thank you, Anurag. Again, when our journey with Shoreline started, I think a little bit less than a year. I remember it was the end of last year. Somehow we discovered Shoreline have these capabilities, and our team took a very agile and incremental approach first did a POC with great support from Anurag and team. That's actually one of the nice things when we work with, again, a startup like Shoreline. They're really willing to work with customers. We basically identify a few areas that all teams say, hey, right now, this kind of thing it's very labor intensive, takes a long time. Let's see what Shoreline can do. So quickly, the team come up with a few things. One area is, as you know, any system or any database systems with, high volume transaction, large queries. Basically, one of the pain points was, you need to keep monitoring the log space. Right, if your log space is becoming dangerously low, you need to going to do something, right? So that's actually one thing. When we have hundreds of thousands of customers on our cloud, we absolutely have to have a good way to prevent running out of log space. As you know, when you run out of log space, your system got stuck, and then the customer basically causes downtime, and we just cannot afford any downtime like that. So that's actually one of the first area we're looking to say, is there a way for us to use Shoreline's tool to, as can we actually find the issue, detect the issue, and monitoring the issue, and then can we have an automatic way to mitigate the issue or to resolve the issue without even any human intervention? That was actually a big success from POC. And since then, we rolled out to production. That's actually one of the very concrete use cases. When you have hundreds, 1,000 servers you have to administer, you have to make sure that that's a very simple initial use case. We found the direct payoff from there. And then the other one is because we have a very sophisticated system is actually distributed. As I said, we have a cluster of many nodes for one installation, one customer, and that customer may also choose high availability cluster, and then failover cluster cross region, right? So how do you make sure if there's anything that's happening, any one of those services, actually in our system, we have at least 24 services. Underneath it, there's a microservice architecture. How do we know if one of the services is down? How can we quickly restart it? Oftentimes, a lot of the services, it's just all you need is just restart. You don't need anything else. Sometimes for whatever reason, it caused a glitch in the service. It got stuck. All you need to do is just restart it. And that's another area we identify, hey, we can actually fully utilize this capability to automatically monitor, which is, getting all the stats from all the servers, right? And then running in parallel. And then when certain things happen, a service down, automatically deploy a script to fix it, to address it, to restart the server or to restart the service. That's another one. It's very, very concrete. We benefit a lot. These are the low-hanging fruits, the simple ones, but I can tell you, even implement those two give us a huge mileage in terms of what we can do in terms of we don't have to scale our team manually, meaning hiring more people. We can actually put those issues not only basically reduce the human effort, but also automate to a point we don't even need to worry about it, right? So that's actually greatly up our time. And now we're actually going into the next phase to look at the new advanced capability like Notebook, just Anurag mentioned, try to actually, based on our incidents handling, troubleshooting, and start creating more sophisticated recipe, right? Multi-step thing, complicated condition, and then try to apply those recipe to service we administer at scale. So again, by having those, we actually noticed this is kind of I just talked to our operations team yesterday. Again, I just want to get up to date. They basically share with me that it's a huge win for them. I think even in the past month, they're seeing saving in the range of 50-60 hours if we don't have this. In terms of a couple of those things, we was able to prevent it using this automated script. Otherwise, it would take at least 2 hours for us to get notified to go into troubleshooting and then to actually apply the action necessary to bring the system back up. So anyhow, this is actually, and then the other thing also we notice we actually start leveraging is with the full power flexibility of Shoreline, we're able to also simplify troubleshooting in a way, as you know, in a distributed system, a particular query may touch a lot of nodes, right? Oftentimes when we have an issue, we want to know what happened. This query got distributed, in terms of execution plan on each node, what step they are, what's the sequence. Oftentimes, this is for big companies. They may afford very expensive to like a Splunk, real-time Splunk, querying, using that to, find that information is not fun either. But we're able to use Shoreline to define a couple of templates, and given a query ID, we're able to get all the essential information together quickly for developers or cloud engineer quickly take a look at it, and was able to piece together all the information in a timely manner, and then find out where the issue is. And also important, when we actually do root cause analysis, when we share with customer what happened, we have all the data already at hand. So that's another actually area we're very excited about. So again, our journey, we have some early wins. We're expanding that with this information. And one last thing I want to share with everybody is that this whole thing, Shoreline enable us to do continuous improvement. It's not an all or nothing. When you're on Shoreline, as I said, start with low-hanging fruits, you can automate, but then you can expand to more sophisticated area. The ability for you to keep applying your root cause analysis, incidents, learning, and expanding your script in terms of detecting, debugging, or applying fixes automatically, the power is huge. So that's why we're looking forward to even stronger partnership with Shoreline to jointly bring up the productivity for our DevOps team. So that's all the time I have. I want to leave. Anurag and I want to leave enough space for people to ask questions, because we are really excited about this tool. We see what we're using is probably only a tip of iceberg. We definitely see a lot more we can utilize this to help us grow on the cloud.
Great. Thank you so much, Jay. So before I jump into questions, one thing I wanted to underscore is what you said about continuous improvement, because cloud reliability is really a journey, no different than quality, no different than security, and you get there one step at a time. When I was at AWS, what I'd ask my teams to do is just extinguish one issue each week. And if you do that, even if you're growing 60% year over year, you get to keep up with it, and your customers get a better experience because you have more customers, they have more issues. That's you discover more things at scale, but individually your reliability goes up because more and more things are being handled in seconds by code rather than by humans, who have to keep so much in their heads. So with that, let's jump to some questions.
Awesome. So it looks like I've got a couple questions about Shoreline and TigerGraph. So let's go ahead and just tackle them from the top. So TigerGraph. So Jay, you said TigerGraph is improving model accuracy by 50%. Could you say more about how you're doing that?
That's awesome. This is often the question we got a lot. What's the magic, right? Actually, if you think about it, it's actually pretty simple. The fact we organize data into graphs. So what is graph? Graph is knowledge, right? Graph is reflect human knowledge, how these data should be connected. And the minute you organize data into graph, then you apply graph-based machine learning, which is those graph algorithm. You actually bring contextual information in your features. So I mentioned early on graph-based features. So what happened, that's actually my own experience before I actually joined TigerGraph. When I was into it, I was an adopter of TigerGraph. We had a fraud detection use case. I work with all data scientists. They were able to demonstrate by adding two features based on graph. One feature is the distance between a particular account or customer in terms of how they transact with others, how they interact with others. The distance between a new customer, a new account, to a potential fraud or a fraudster, known fraudster, bring that information as one feature. And then the other feature is more about community detection, really natural cluster people or transaction usually grouped together. Bring those two features into the machine learning, deep learning model. The model accuracy recall was basically improved by 50%. Because machine learning in general, when you do feature engineering, those are flat key value pairs. Machine, doesn't know their intrinsic relationship. They try to reverse engineer the relationship by running this deep neural net, right? Use mathematical model, try to detect patterns. The minute you ingest graph-based knowledge in learning, suddenly the machine learning is a lot more smarter, right? So that's why it explains why it can bring fraud detection model accuracy recall, for example, efficiency or accuracy from 65, 70% to 80, 85%. That's huge. And that kind of percentage change will help people save a lot of money in terms of fighting fraud. And this is not alone. We also see other customers did the same thing. We have a new offering called Machine Learning Workbench. It's available. There's a free evaluation version. We have a test data set to demonstrate with or without graph, or with or without TigerGraph's graph-based features, your model performance can be varied by 20%. So it's a really concrete use case everybody can try.
Awesome. Thank you for that. Our next question reads, how can Shoreline help debug needle in a haystack type of issues for TigerGraph?
So I think that gets exactly to the parallel distributed execution. So there's a problem, you don't know where it is. And so, the ability to go and run something like a top command or a grep command across the entirety of your fleet, just find the subset where some anomaly is running, and then be able to focus on that subset and then run more commands on it. That's kind of how you debug if it were a single host. That's really how you'd want to debug in this world. Let me try to make that come alive. So we have a different customer who is in financial services and payments, and they're very concerned with the potential for other people running fraud inside their environments by injecting bad processes. And so you can generate a list of either bad processes or expected good processes, and just make sure as part of your regular PS on the system, like, are there any bad processes running? If so, I need to quarantine that node or kill that process. Are some of my good processes not running? Well, in that case, I'd better kick it and restart it. That's similar to the one Jay was talking about. Now, we can all manage that on an individual node. The problem is that it gets super complicated when you're starting to run tens of thousands of containers. And so the ability to manage your entire fleet as though it's one node and do what you would have done anyway is what is sort of the magic underneath Shoreline.
Awesome. Jay, it looks like you kind of touched on this question that we received in the chat, but I'll go ahead and just bring it to the forefront. Will TigerGraph have a separate data lake where it will gather all these data sets?
Yeah, that's a great question. I think think about TigerGraph, as I earlier mentioned, is almost like a Teradata for the graph. Just like any other database system, we'll have our own a proprietary persistent store optimized for graph processing. So by default, if we have a cluster of 40 servers, on each servers we use local storage. That's the typical share nothing parallelism we accomplish. So in that sense, we have our own storage, together with the compute units. But because we moved to the cloud, we can also allow you to configure those storage to fully leverage the native cloud storage as well, the blob stored, S3, and then GCP's blob store as well as Azure. So with that, then in some sense, could be your data lake. So TigerGraph is known for performance and scale. That's the huge differentiating against all the other graph database vendors. There's a performance benchmark called LDBC. We already cracked at 36 terabytes level. We are the only and the first and only vendor. And other vendors have not published 1 terabytes level for the most complicated, graph analytics query. In our lab, we're already handling about a cluster of 100 nodes, 100 terabytes, and our goal is to reach petabytes. When we reach that level, then we will argue your entire lake should be a connected graph instead of just mirroring of your relational tables right over there. So that's all ambitious. So we're not there yet, but as I said, we actually want to go there. But ultimately, think about all your data is already pre-organized, materialized, join is already done, already connecting the meaningful way. How powerful it is for you to do machine learning, for you to do deep analytics. That's our vision.
And you'll certainly ingest from a lake.
Yes, we can ingest from lake as any other thing, but ultimately we can also replace lake if we want to.
Yeah. And that's, I think, eventually super important, particularly for knowledge graphs, where you want to collect a bunch of data together.
Yes, absolutely. And that's the reason we need Shoreline, right? Just because it's distributed, we have a lot of servers. We have to have the ability to diagnose all the nodes at the same. We cannot go to each individual node to do troubleshooting, diagnosis. That's not going to work. Yeah.
You can see both Jay and I strongly believe in distributed computation.
Yes.
Any other questions, Cody?
We've got a couple more. Anurag, I see how Shoreline can help with simple problems like a disk filling up, but what can it do if we're in the middle of a major outage?
That's a great question. So I would say, both things are important, right? Because the fact is that a lot of the issues are simple, and that's a really terrible thing to invest human capital on, both because of the expense, the time, and error rates, right? So it would be great if that were all that we could do. But in the things that are more sophisticated, the thing you really want to do is to make sure, is it one of my already identified problems? And a notebook is great at figuring that out, because you can run through all of your sort of, so to speak, pre-flight checks or other things like, can I reach my DNS nodes? Server is it stale? Do I have connectivity from everything to everything? Is there a service which has suddenly widely higher latency? So there's a bunch of checks that you can do to narrow down the sphere, and then hopefully once you've narrowed it down, if either it'll be something that you've seen before, or it will be something that's brand new. If it's something you've seen before, hopefully you can use a notebook as well as a recipe for that. If it's something you haven't seen before, then that's where the parallel distributed debugging comes to play, where you can go and just try to quickly figure out things. I remember, there were times at AWS that the way I handled that was by getting 30 engineers and saying, these are your 20 servers each, go and run this command. That's not, it's one form of doing parallel distributed execution. It's hardly the best form, right? But you do what you have to, right, in the heat of the battle.
All right, so it looks like we do have one more question. So to our audience, please do send any questions you may have. So what is the cost of downtime at TigerGraph?
Wow. If anybody is working on mission critical application, this question is really tied to how mission critical your application is. So for us, we help more than 100 enterprise customers. Think about the other thing I forgot to mention during our introduction to our product. Our product, oftentimes people, definitely there's a use case of batch-based processing. So for batch-based processing, this downtime may not be as significant, but we also support HTAP. That means we can allow you in real time update your graph and then also trigger real time analytics. And downtime on that, the cost could be huge, right? Think about fraud. So one of the use cases we did was China Mobile, in an early use case. They literally using TigerGraph to detect basically spam calls. And that has to be within 100 milliseconds, right? If it's down, that means you'll get flooded with more spam calls. So I think the cost of that is mostly not us, is actually customer. But if we cannot get their system up, they'll trust less on our product and services. So the cost could be huge, right, in terms of customer retention to meet their need. So I just, in some sense, the actual answer is it depends, but very likely is how critical our customer is using our service. And we know there's a lot of customers do want a real-time response instead of just batch-based processing. So this is extremely important to make sure our systems
You're part of their live transactional flow.
Exactly.
Right.
Exactly.
And so I don't have TigerGraph. I'm letting a bunch of fraud transactions through, or
that's a cost.
Maybe just not accepting transactions, which is even worse, right?
And then the other thing is actually there's also there's another use case called AML, anti-money laundering. That causes, if you fail to catch them or prevent them, then you get fined big time by regulators.
And
right?
big time is like hundreds of millions.
Yes. Yes. So again, the cost really tied to how people is using TigerGraph for their mission critical app, right? And those have a huge consequences if their system is not up.
All right. Well, that is the last question I'm seeing. So I'm going to give our audience about 25 more seconds to send in any questions while I give away just a couple of gift cards. So these are for 4 $25 Amazon gift cards. Our 4 winners are, so we've got Kazi Z, Chris P, George B, and Tan M. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim those gift cards. But if you don't happen to see that email, check your spam folder. I'll also take this opportunity to remind our audience that this session was recorded. So should you want to rewatch or share with a friend, the on-demand recording will be made available on devops.com/webinars, and just be sure to look in the on-demand section. All right, folks, I'm not seeing any more questions. So Jay and Anurag, I'll give you the floor one more time if there's anything you'd like to say before we close out.
I just want to thank Jay for the partnership. I mean, TigerGraph is an extraordinary product, and I'm grateful for the opportunity to work with him and the team.
Yeah, again, me too. I think the experience partnering with Shoreline, Anurag and his team is exceptional. It's actually a great win-win. I will call for everybody here. Both companies, we're a startup, we're very focused on delivering real value because we don't have any time to waste. So when we have those things, please try it out. Shoreline's solution, as well as also check out TigerGraph if that's relevant to your business, because what we want to do is making sure truly make a difference in your environment, in your application, in your business case, because that's what we are here for. Both of us are very passionate about parallel distributed computing. As you know, that's the future. Big data is about parallelism. Without that, we cannot do anything. So whether it's applied to DevOps, whether it's applied to your data, please check us out. Thank you.
Well, Jay and Anurag, thank you both so much for taking the time to join us. I'd also like to thank Shoreline and TigerGraph for sponsoring today's program. So for our audience today, thank you so much for joining us. We do really appreciate you spending time with us today. We want to ask for just one more moment of your time. As soon as we close out, a survey should pop up on your screen. We would really like you to fill that out. So if you would do that for us, that would be great. Anurag, Jay, thank you so much. To our audience, have a great day. We hope
Thank
to
you
see
for hosting,
everyone
Cody.
soon.
Thank you.
Of course. Bye, everyone.